Hey guys, I am going to discuss the method Cardon method. It is basically used to find the roots of cubic equation. So now first of all consider let us consider general cubic equation, that is x cube plus ax square plus bx plus c is equal to 0, where the coefficient a comma b comma c belongs to the set of real number or set of complex number. So now we need to convert we need to convert this general cubic equation into x cube plus qx plus r is equal to 0. So that means we need to remove the second term of this general cubic equation. So now, so let us suppose this is our equation 1 and this is our equation number 2. So now further we need to substitute, or we need to put x is equal to y plus z in equation 2. Then y plus z whole power 3 plus q times of y plus z plus r is equal to 0. So now here a plus b the whole cube, that is y cube plus z cube plus 3 times of yz multiplied to y plus z plus q times of y plus z plus r is equal to 0. So now here y cube plus z cube plus 3yz and value of y plus z is equal to, that is x. It will give x plus q times of x plus r is equal to 0. So now further it can be written as y cube plus z cube plus, that is r, and take the x as a common from these two terms. So it will give 3yz plus q multiplied to x is equal to 0. So now further we need to compare this equation. 0 plus 0 times of x is equal to 0. So further comparing we will get here y cube plus z cube plus r is equal to 0 and 3yz plus q is equal to 0. So here will be, that is yz is equal to negative q by 3 and y cube plus z cube is equal to negative r. So this can take the cube on both sides. Here it will give y cube z cube is equal to negative q cube over 3 to the power of 3, that is 27. So now consider this sum of roots and product of roots. So we can take this equation number, that is 3. Now we can take this equation number 3 and we have to take this equation number as a 4. So now further we can construct the quadratic equation. The quadratic equation with roots y cube and z cube is, if the roots are y cube and z cube, we can construct the quadratic equation, that is x square negative sum of roots, that is y cube plus z cube multiplied to x plus y cube multiplied to z cube product of roots is equal to 0. So here x square negative sum of roots is given as, that is negative r multiplied to x plus y cube z cube, that is negative q to the power of 3 over 27 is equal to 0. So further it will become, that is a x square plus r times of x, sorry, that is negative q to the power of 3 over 27 is equal to 0. And this is a quadratic equation. So uh, by comparing, by comparing with Sridharacharya formula, that is a x square plus bx plus c is equal to 0. So now here value of x will be, that is negative b positive negative square root of b square negative 4ac over 2 times of a. So by using this Sridharacharya formula, we can find the value of x here, that is capital X, that is negative r positive negative square root of b square, that is r square negative the 4 times of 1 multiplied to negative q to the power of 3 over 27 over 2. So further simplifying, this value capital X is equal to negative r positive negative square root, that is r square plus 4 q to the power of 3 over 27 over 2. So divide the numerator by 2. So it will divide the numerator by 2. So it will become, that is a capital X, that is negative r by 2 positive negative square root of r square by 4 plus q to the power 3 over 27. So now this will be split in two parts. That is, because x had two root y cube z cube, so we can write here y cube is equal to negative r by 2 positive square root of r square by 4 plus q to the power of 3 over 27, and second, that is z cube is equal to negative r by 2 negative square root of r square by 4 plus q to the power 3 over 27. So as we know that we can take the y as a cube root on both sides, that is negative r by 2 positive square root of r square by 4 plus q to the power of 3 over 27 to the whole power 1 by 3, and z is equal to negative r by 2 negative square root of r square by 4 plus q to the power 3 over 27 to the whole power 1 by 3. So now we can take this term as a capital A, and this whole term we can denote as capital V. So we can write here y is equal to a to the power 1 by 3 and z is equal to b to the power 1 by 3. So further we can find the value of x, that is y plus z, and that is a to the power 1 by 3 plus b to the power 1 by 3. So this is, let us suppose construct the equation number 5. So now we can construct let us suppose that's the equation number 5, and take this, that is equation number 6. So further we can write here, that is, this is the solution of equation, that is 3, and from equation 5 it is clear that y and z have three values each. So that is, if y and z three value, then how many values of x? That is a 9, total 9 combinations. So we can write here x has in all 9 values, but equation 3 but equation 3 is a cubic equation. If the cubic equation, so it has 3 roots. If it has 3 roots only, and also y and z from equation 6 must satisfy equation 4. So therefore we can write the cube root of y to the power 3 are y omega and y omega square, and the cube root of z to the power 3 are z omega and z omega square. So out of these 9 roots, we select the values satisfy equation 4, and which are which are so that pair will be what? That is y comma z. Second, that is y omega comma z omega square, and here will be y omega square comma z omega. So roots are hence roots are that is x is equal to y plus z and y omega plus z omega square, and y omega square plus z omega. So we can say, so these are our required roots of the given general cubic equation, and this is our required final answer.